let's keep moving on, and let's talk about model design. So, in this section, we'll walk through the model design for NERPMAB, and generally, this is how you would display a model design. It's a flow chart, to explain what are different steps that are involved in a model, and how they connect with each other, and in what sequence are the steps implemented. So the gray box that you see here and all the sub boxes within them, those are all the model steps that are implemented within Visum. And then all the boxes that are outside of this grade PTV Visum box, they are sort of the third-party tools, but Visum interfaces with them using the Python API. So that's the basic idea about software design. So everything happens within Visum, and then anything outside of Visum is interfaced using the Python API. So let's if you open the Visum version file and look at the procedure sequence. So let's quickly do that here for a minute. So to open procedure sequence, I can use a quick access toolbar, and if you see this icon here with a small blue down pointing arrow, if you simply click on that, it would open the procedure sequence. And let me just quickly close the network editor window here for a minute. And if you go through these, you would get an idea about what model steps are involved, and you can get an idea about the basic design of the model itself. For this is true for any Visum model. You can walk through the procedure sequence and understand. So here, let's say the first step is calling all the synthetic population and DASIM data tools, and then it goes to network preparation, and then there's a bunch of demand calculation, and then assignment, and then convergence and feedback, and then finally doing network assignment, and then generating reports and summaries. And this is exactly what I just presented here in this flowchart. So let's go through these steps quickly, just to understand, how the model system is working and how the model is designed. So the first step is land use data export. So all the data, input data, is stored within the Visum version file. And I talked about how there are two geographies in NERPMAB. There is MAZ and TAZ, and I'll show you how those geographies are represented in the model structure. But the first step is to export the land use data to be used by other third-party tools such as Population Sim and DASIM data tools. And then at this step, the TAZ data is aggregated from the MAZ data, and then it is exported for auxiliary models. So there are, since DASIM generates only residential demand, there are other models to generate auxiliary demands, such as truck trips or external internal visitors, etc. And one thing to note here is all the auxiliary models, they remain pretty much unchanged, or like they are similar to a previous model, just they are implemented using Python now, but the format pretty much remains the same, and they operate at TAZ level, but DASIM operates at MAZ level, and that's why for MAZ data is exported for DASIM and Population Sim, but for all the auxiliary models, we still export TAZ data. And while I'm going through this step, I'm just walking you through this, but all of this happens automatically when you run the model. You don't have to do any of this manually. Okay, so after land use data export, the next step is running population sim and DaySim data tools, which prepares inputs for DaySim and various auxiliary models. And then next step is to prepare the network and then generate unloaded skims. So preparing the network would include things like you know applying the speed capacity lookup and coding speeds and capacities on links, or setting turn penalties, or fair points for transit network and things like that. And then once that is done, we generate unloaded skims, because at this point there are no volumes on the network, so only unloaded skims are highway skims are generated at this point. And after that, the next step is the generating the auxiliary demand. And as I mentioned, the auxiliary model, they work at the TAZ level. There are truck trips, external, internal, external, and special generator, visitor trips, etc. Those demand segments get generated at this step. And then after that, transit skims are generated for peak and off-peak period. So in the first run, since there are no volumes, so unloaded skims are generated. But if you would see here, there is a feedback loop. So for subsequent iterations, the transit skimming updates the runtimes for buses based on congested volumes, and then the skims are generated accordingly. And transit skims are required for DaySim. So at this point, Visum interfaces with DaySim, and at this point, DaySim has all the inputs that it needs. From population sim, it gets synthetic population, and then from the DaySim data tools, the land use data is in place, and then from Visum, the transit and highway skims, they are exported in the format required for DaySim. And then DaySim generates trip tables or trip lists for the 24-hour period. And then in the assignment preparation step, those trip lists are converted to TAZ level trip tables, and then they are combined with the auxiliary demand. And the trip tables are segmented by there are 5 modes: SOV, HOV, 2, 3, truck, and transit. And then there are 4 aggregate time periods: AM, midday, PM, and evening. And then once the assignment data is ready, the trip tables are assigned to the network, and the assignment is performed for all 4 time periods, aggregate 4 time periods. And after each assignment, the link volumes are averaged to for better stability, or for equilibration of the model system. And then skims are computed based on those averaged link volumes. And then after that, the convergence is checked for. There are 2 convergence criteria in NERPMAB, maybe a VMT based convergence criteria and a link volume based convergence criteria. And if the criteria is not met, then the controls go back to the auxiliary demand step, and the NERPMAB has been set up to run a maximum of 7 iterations. But if the convergence criteria is met, then the model can break out of the feedback loop before 7 iterations. And then after this, once all the feedback iterations have been completed, next is transit assignment, which is performed for both peak and off-peak periods at the end of all iterations. And then after that, the next step is reporting. And in this step, highway assignment validation report is generated, and we will talk about this more when we tomorrow when we when we review model outputs. We'll go through this HTML dashboard. And then as the last step, the model calls the DASIM reporting tool, which processes DASIM outputs, and it also generates, the Excel summaries that we looked at, which can be used for, calibration and validation. So those Excel summaries, they also compute adjustment factors. It has survey data, so it generates summary comparisons and also, adjustments for calibration.